Hello learners, welcome to this course on practical machine learning using Google Colab. In this tutorial, we will be discussing about the steps in supervised learning process. So there are 5 major steps involved in a supervised learning process. So let me just recap on what is a supervised learning process. So in a supervised learning process, we have a data and its associated ground truth value. So ground truth value can be a label which is related to the content in the data. So once I have a data with the ground truth value, when this data is given to a machine for a prediction, the machine makes a prediction. If it is a right prediction, there is no issue in it. If it makes a wrong prediction, then we can able to correct it because we already know what is the ground truth value of the data. So such type of learning process is called as a supervised learning process. So we have 5 major steps in the supervised learning process. They are collection of data set. Once we have collected the data set, we need to split the data into training data and test data. And then this data can be used as it is to train a machine, or we can use it for extracting the features from the data, and then the extracted features can be used for teaching a machine. Then finally, an evaluation process takes place. So let us look at each and every step in detail. So the first step involved is collection of data set. So this is a very important step in any machine learning algorithm. So if our data is poor, then whatever we do with our machine learning algorithms, we would not be able to get a better prediction results. So we need to take care in collecting a good data. And also, as I said earlier, a machine learning algorithm, its performance gets improved as it is exposed to more and more data, which means I need to have more amount of data in my data set. We need to have a more amount of data in a data set so that the experience gained by a machine will be extensive. And also there is another factor involved while collecting a data, which is nothing but we should have a variety in the data. It should not be something like monotonous or homogeneous in nature. So the data should be having a variety in it. For example, if I want to have a machine to make a cat identification from the images, then I should have a data of cat in standing position, sitting position, in running position, different colored cats, different sized cats, and close-up shot of a cat and little bit long shot of a cat captured under different lighting conditions, cat from different countries. So like that, we should have a variety in the data. It should not be something like a simple monotonous data. So 2 important factors we should consider while collecting a data set. One is we should have large number of data available in our data set. Second one is we should have a variety in the data. So the data should have all the possibilities should be included in the data, because in a real-time situation we don't know what type of input data will come to our machine. So our machine should be able to predict in such a situation. So it should have that experience of visualizing the data in similar situations earlier. So once we have collected the data set, we go on to the second step, which is your training and test split. So now we have a data set, it needs to be splitted into 2 categories, training data and for testing data. So training data is used for teaching the machine. So this makes the machine to learn from the data, training process. Once our machine is learned, then we can test how well the machine is learned by giving the test data. So what should be the ratio between this training and test data? So different research groups have carried out different types of segregation of training or test data. Certain research group, they have used 66.7% of data in training and 33.3% for testing. Same way, some other research group, they use 75-25, 80-20, 90-10, etc. So there is no definite rule that I should have something like 80-20 should be the training and test data. So it depends upon the application. So you need to, this is a iteratable parameter. So in a machine learning algorithm, you need to change this training and test data split up in different ratios, and you have to check which data split ratio gives you a better performance metrics. Then you have to stick on to that particular data split ratio. So it depends upon the application. We don't have any unified rule of this training and test data. So one thing you have to remember is I should have more number of data for training when compared to testing. So that is a basic condition which needs to be satisfied. So training data should be more when compared to your test data. Once we have split the data, so we need to train the machine. So the training can happen in two ways. One is I can give the data as it is to the machine for it to learn. We take the raw data and give the raw data to our machine for learning purpose. Another option is we can take the data, raw data, and use some feature extraction algorithms. We can extract some features out of the data, some statistical parameters. If it is an image, I can extract the color information, texture information, shape information. So like that, we can extract some features and use that features to teach the machine. So there are two ways in which a machine can be learned. One is I can use a raw data for teaching a machine, or I can use a extracted features from the data for the machine to learn. So if I use a raw data, which means the machine needs to work with an enormous amount of data. So its computation time will be little bit on a higher scale while training process. Whereas if I use some feature extraction algorithm, which means I'm abstracting certain features from the input data, which means I'm not using the complete data, I'm extracting some features. So the number of features which we get will be less. So thereby the computation time for a machine learning algorithm in the training process will be low. So depending upon your application, you can decide whether you want to use the raw data as it is for teaching a machine, or you are going to use some feature extraction algorithm, extract the features and use the features for training a machine. Once the machine has learned on the data, training data, then we can test the machine, how well the machine has learned. That is done using your evaluate classify. So we can evaluate the machine by providing the test data. By giving the test data, we can see how well the machine has learned. That we can understand before using the model in a real-time scenario. Right? So remember here, whatever we do, training as well as test happens within the data set which we have collected. Once we have trained our model and tested our model, then we can put this model in a real-time scenario and it can be exposed to a real-time inputs. And we can ensure that whether it is working properly on our model. So these are the 5 major steps involved in a supervised learning algorithm. So the first step is collection of data set. 2 important things we should consider while collecting a data set. One is we should have a large number of data in our data set, and second one is we should have a variety in our data. Once data set is collected, we need to split it into a training data and test data. So here the training data should be more in number when compared to the test data, and there is no definite logic behind splitting up of this training and test data. So it needs to be found out while running an application. You need to try out with the different data split ratios, and you have to stick on to the ratio which provides you a better result. So once the data is split into training and test data, then the data can be given as it is in the raw form to train a model, or we can extract the features from the data, and the extracted features can be used for training a model. Once the machine has learned, we can evaluate the machine by providing the test data. So whenever we try to train and test a machine, we need to evaluate its performance. How we can evaluate its performance? Through some metrics. We have performance metrics which needs to be computed, which determines how well the model is performing. So here I show some performance metric terms. So for this, let me explain it with an example. So let us consider I have an input image. I have an input image which contains a cat. Let us assume I have a cat. Something like this. I have a cat. So this is a supervised learning. So a data is associated with a label. So here our machine will be trained to identify a cat in an image. Our machine will be trained to identify a cat in an image. So let us take the positive class as cat. So this cat I am going to take it as positive class, and other categories, if the image contains a man or some other animals, then it is going to be considered as negative category. So the ground truth value can have a positive or negative. Positive means our machine wants to find cat, that I have taken it as positive category. Other categories are coming under your negative categories. So I am going to have the ground truth value. This is the ground truth value. Ground truth value. So here the positive, I am going to say it as a cat, and negative other categories in our image. So this is the actual labeled for our input data. So once this data is given to a machine, now the machine makes a prediction. So it says it can be a cat or other category. So this is your machine prediction. So this is a predicted class by the machine or the model. Right? So now let us see. If our machine makes a prediction cat and the original label is also cat, which means both are positive, right? So then it is called as true positive. It is called as true positive. So our ground truth value is also positive. The machine prediction is also positive, and it's a right prediction, right? So then it is called as a true positive. Same way, our machine makes a negative prediction, which is other category, and the actual ground truth is also other category, negative, which means it is called as a negative. So negative is predicted by the machine and it is true in nature, right? So negative is predicted by the machine and it is true, it is right, it matches with the ground truth value. So it is called as true negative. We have other two categories, something like our machine makes a prediction positive, but the actual ground truth value is negative. Okay, so here it's a wrong prediction, right? So our machine makes a prediction to be cat, but our image contains some other thing. Okay, it is other category, which is called as false positive. Okay, our machine says it is positive, right? But this positive is not right, it is wrong. So it is called as false positive. Same way, there is another category. Our machine makes a prediction negative, but this negative is wrong because actually the ground truth value says it is positive. It's a cat category. So it is called as false negative. So we need to compute these four parameters: true positive, true negative, false positive and false negative. Once we have identified these 4 parameters, we have some mathematical formulas to compute different performance metrics. So one of the important performance metrics is accuracy. For computing the accuracy of the model, accuracy in prediction of the model, so we need to take true positive plus true negative divided by all the possible combination. True positive plus true negative plus false positive plus false negative. So this accuracy is a very important parameter in a machine learning model. How accurately our model makes a prediction. So it depends upon true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. And one important thing to consider, this accuracy can be taken as a valid performance metrics if I have a balanced data set. Right? If I have a balanced data set. What do you mean by balanced data set? I should have almost equal number of data in each category. We should have almost equal number of data in each category. For example, here I take 2 categories, cat and other. So I should have almost equal number of data. For cat, I should have something like 100 images, and for other category also I should have something like 100 images. If I have a balanced nature in our data set, then we can make use of this accuracy. If I have an unbalanced data set, in case of a medical image processing, whether our machine can able to identify whether we have a cancer region in a MRI image or not. So in that case, the number of images with cancer will be very less when compared to the images without cancer cells. So there I have an unbalanced data set. In that case, we should not make use of this accuracy as a parameter. We should have other performance metrics. So other performance metrics, something like precision. So precision is computed by true positive divided by true positive plus false positive. Same way, recall or sensitivity is computed by true positive plus false negative. So once I compute this precision and recall, I can use it in this equation. 2 into precision into recall divided by precision plus recall, I can compute the F1 score. So this F1 score is a very good performance metric if I have an unbalanced data set. If I have an unbalanced data set, then this F1 score should be high so that our model or machine can make more right prediction on a new data. So this formula can be used for computing the F1 score. So there are other performance metrics also like specificity, true negative divided by true negative plus false positive. Same way, negative predictive value like true negative divided by true negative plus false negative. So like that we have many such performance metrics. So any machine learning model needs to be evaluated by computing the performance metrics. If the performance metrics are good, then the model is expected to do well in a real-time scenario. So that is how a machine learning model is evaluated. So in this video tutorial, I have discussed about the different steps involved in the supervised learning algorithm. So the first step is collection of data set, then divide the data set into training and test data, then use the raw data to train your machine or extract the features from the data and use it for training your machine. Once our machine is trained, evaluate the machine. So the performance of the model is analyzed using this performance metrics. If we have a balanced data set, then accuracy will be a very good parameter. Whereas if I have an unbalanced data set, then we need to compute precision and recall and use this parameter to compute the F1 score. So which gives a better standardization for our machine learning model to work in a real-time scenario. Thanks for watching. Please subscribe for more technical learning. Thank you.